All right. So, difference of squares is a very specific type of binomial pair that we can factor to get two binomials. Now, thinking about the title, difference of squares, difference means subtraction, right? So this is talking about a subtraction. And of course, this is a subtraction of squares. So these questions have two terms, and one of them has a minus sign. Both terms must be a perfect square. So the pattern is if you had like a squared minus b squared. Here I'm getting a difference of squares. Now there's a beautiful pattern that happens that this becomes a minus b times a plus b. Now we're going to talk about how that works and how exactly you learn to recognize them. But like I said, the middle sign is negative, so it's a difference, and the two terms are perfect squares. Now the solution are what we call conjugate binomials. And these are binomials that have the same terms except the middle sign have the opposite signs. So x plus 3, this is bad, sorry, and x minus 3 are conjugates. This should say x plus 3 and x minus 3. Those are conjugates. So they're identical except for the sign, okay? That's the only thing that's different. Now, when conjugate binomials are multiplied, the middle terms cancel out, and the result is a difference of squares. So here, for example, we multiply using FOIL, right? So we're using FOIL here. So this is our first, x squared. Outer is 3, x times negative 3. So we did it in the wrong order. Oops. Inner last. Never use someone else's notes. That's your lesson for today, ladies and gentlemen. In any case, what happens is positive 3x minus 3x equals 0, right? So they cancel each other out. So that's kind of what happens, and we're left with this difference of squares. So if you see a binomial where you have a square subtracting a square, all you have to do is take the square root of both terms and subtract them. So the square root of this, so you're going to subtract them and add them, okay? We're going to do some practice with this, and of course you can always factor FOIL to check. So steps: factor out the GCF if possible, be sure to factor up the negative, and don't forget to include the GCF as part of your final answer. That's been your step one for almost everything, okay? To factor this problem into the form of a plus b times a minus b, you need to take the square root of both terms, and it will only work if the terms are perfect squares. So sometimes you can't see the perfect squares until you take the GCF out, okay? So that's basically the pattern. And of course you can check your work by expanding, okay? Always check to see if any of the remaining factors can be factored further, okay? So let's do some practice with this, because this is actually going to go pretty quick. So here I asked myself my questions, right? Are x squared and 4 perfect squares? Yes. Okay, so what's the square root of x squared and what's the square root of 4? Well, the square root of x squared is x, and the square root of 4 is 2, so we're going to have x plus 2, x minus 2. Now, important thing to note, ladies and gentlemen. You can have them in the opposite order. It doesn't matter. These are identical, okay? So it doesn't matter which order you put them in. They are identical, okay? So I don't know. I always love difference of squares because it seemed like a magic trick with the middle term dropping out. And we can check this using FOIL. So we're going to do that here as soon as my screen finishes. So using FOIL, let's just see what happens. I get x squared plus 2x minus 2x minus 4. These two terms cancel out. And I get x squared minus 4. So check, it does work. Okay, so let's keep going. B squared minus 81. B squared is a perfect square and 81 is a perfect square. So the square root of B is B. Square root of 81 is 9. So I know I'm going to have B plus 9 minus 9. And again, doesn't matter the order. You can go minus 9 plus 9. It will give you the same answer. Okay, these are interchangeable. So it's basically just take the square root of b squared, which is b, and the square root of 81, which is 9. Okay? Next one. And now you're looking at it going, yes, there's an x4 there, and there's a 128 and a 2. Well, we want to factor out the GCF first, right? Okay. So we're going to factor out that. We're going to get x to the 4 minus 128 divided by 2 is 64. Now, x to the 4 is a perfect square. What do you mean, miss? Well, perfect square root of x to the 4 is x squared. Woo! Square root of 64 is 8. So let's do this one. Okay? So from that, 2x squared minus 8 times x squared plus 8. Okay, now sometimes when we do this, this might be a difference of squares. It's not in this case because 8 is not a perfect square, but occasionally we do get an x squared minus something. So we need to make sure we've gone all the way. In this case we have, so we're good to go. And obviously to check this, you could just use FOIL to check. And I'll leave that to you to do that check. Alrighty, next one. Are these perfect squares? Well, I think they are. Let's check. 25x squared, well, that's the square root of that is 5x. And 49 squared, the square root of that is 7. So yes, they are perfect squares. So it'll be 5x minus 7, 5x plus 7. And again, the order doesn't matter. You can switch the order. They still are the same. Okay? Let's keep going. Now, remember, we have to do our GCF first, right? Because right now, those don't look like perfect squares to me. But I can take a 10 out of both of them, and I can take a z out of both of them. So I'm going to be left with x squared minus 36y squared. Are those perfect squares? Well, let's take a look. Square root of x squared equals x. Square root of 36y squared equals 6y. Okay, square root of 36 is 6. Square root of y squared is 6y. So let's pop that in. We keep our GCF. Don't lose it. We found it. We don't want to lose it. It'll be x minus 6y times x plus 6y. Okay? Alrighty. Next one. I just love these. These make me so happy. Now this one, it's going to be tricky. You got to keep factoring. So, are these perfect squares? Well, let's see. Square root of 16x to the 4 is 4x squared. And the square root of 81 is 9. So let's do that. 4x squared minus 9 times 4x squared plus 9. Now, you have to keep factoring until you're done. This is also a difference of squares. So what do you mean, miss? Well, 4x squared equals the square root of that equals 2x, and the square root of 9 equals 3. So we can take this one further down to 2x minus 3, 2x plus 3. And then we have our original. We have to keep the original one from the expression as soon as my screen is done saving, 4x squared plus 9. Okay, I'm just going to draw a line to separate my squares. Okay, so this would be my final answer. I cannot factor any further, but you have to do the difference of squares again there because it's not done. Okay, and our last example, 4 minus 100x squared. I've got to take out my GCF first, even though I can not do it. And I'm going to also rearrange. Why am I rearranging? Does it matter? Oh, because of the order, right? Okay, so negative 100x squared plus 4. So I now have a negative in the front, but I'm going to divide by negative 4. So I'll get 25x squared minus 1. You're saying, oh, a 1, miss. What's going on with that? Well, let's see. Let's first deal with their 25x squared, and it will be 5x. Well, the square root of 1 is 1, so I can keep going. And it is a difference of squares. So it'll be 5x minus 1, 5x plus 1. Okay? Now, you could still get a difference of squares without that, but this is a better way to do it. Okay? Because we want to make sure we're in standard form, and in standard form, the x squared would be first. Okay. Hopefully you can see the pattern. I love difference of squares. They make me happy, and I really don't know why. There are certain math things that just makes me go, oh, that's so cool. So you're going to do some practice with these. I tell you, you use them all the time. My son's doing math 30-1, and every once in a while there's a difference of squares, and he'll go, how did you do that, Mom? And I'll say, it's a difference of squares, and it goes, ah, okay? It's just a cool trick. So keep your eye